to what we have for today's class. Today's class is meant for the SS1 um, section of the senior secondary school. So we're going to be going straight into what we have for today. So today we're going to be treating states of matter, which is the endpoint of the class that we began last week with SS1. Can you see what's on the screen right now?
Yes.
Beautiful. Dominic, is that you? You're welcome.
Yes, sir. Good evening,
Yo,
sir.
good evening, Dominic. How are you today?
Fine, sir.
You're welcome. And I learned you guys resumed school today. Is that correct?
Yes, sir.
All right, beautiful. So I'm looking forward to helping you make the most of your academic year. Okay, so without wasting much time, let's get into what we have for today. Now, last week we treated the John Dalton's atomic theory of matter. Did you remember that?
Yes, sir.
And then we talked about some of the ideas that that theory actually propounded. And here they are on the screen right now. We started off by saying that he stated that all matter is made up of very tiny particles. Those particles are called atoms. Did you remember that?
Yes, sir.
Beautiful. And then we said that they are indivisible, they cannot be divided, or they cannot be created or destroyed. And then we said a few other things right here on the screen. Now, that theory, at a point in time, as research advanced and as more discoveries were made, it was discovered that some of the things that were said and that are written on the screen right now were not totally correct. For example, now let me refresh your memory a bit. Did you know that there was a point in time on Earth when scientists once believed that the world was flat? Did you know that?
Yes.
Good.
Yes,
But
sir.
as more discoveries were made, scientists actually discovered that no, the world was not actually flat. The world was round or in a spherical shape. In the same way, as scientists made more discovery, this atomic theory, there were some things that they found out to be not absolutely correct, and then they made some adjustments to the theory, and that's why today we have the updated form of the atomic theory. So here is what we're going to do. We have 6 points on the screen. David, you read the first two, and then Dominic, you read the second two, and then I'll read the last two, and then we'll get into states of matter that we're going to deal with today. All right, David, you're up now.
Okay. All matter is made up of atoms,
Mm-hmm.
which are extremely small particles that can take part in chemical reactions.
Good.
Are they visible? They are made up of subatomic particles, brackets, proton, neutron, and electron.
Good. Good. All right, Dominic, you're up now.
Atoms of the same element are not always identical. They can exist as isotopes. Same element, different numbers of neutrons, different masses. Atom of different elements differs in mass, size, and other properties.
Yes, and then the final two, that's for me. Atoms combine in simple whole number ratios to form compounds, but they can also form more complex structures like polymers and crystals. And then finally, atoms can be transformed. They can change into other atoms in nuclear reactions, unlike what Dalton thought. So this is the updated form of the atomic theory that was proposed by John Dalton. Can you see what's on the screen right now? All right, so today we're
Yes.
looking at the states of matter. And at the end of this class, there are some things that I want you to be able to do. I have three objectives that I want us to be able to achieve by the end of today's class. Objective number one, I want you to be able to relate the particulate theory and then to observe properties like diffusion, compressibility, and the Brownian motion. I want you to be able to give simple examples and illustrations of particles in everyday life. And then finally, I want you to be able to appreciate the importance of the particulate nature of matter in understanding chemical reactions. Who is ready for today's class? And who is as excited as I am?
I
Beautiful. So we begin with what the states of matter are. Now, in elementary science, matter exists in three states. As you proceed in science, for those of you who are going to be scientifically inclined in the higher institutions, you actually discover that they are more than three. But for your level, matter exists in three basic states. And you already know what those states are. David, what are they?
solid, liquid, and gas.
Thank you very much. They are the solids, the liquids, and they are the gases. Now, these states of matter are explained by the arrangement and the movement of particles. Are we together now? In our previous class, we stated that matter is made up of tiny particles. Those particles, however they are arranged, to a large extent, it will determine the state of matter that will be in. So, for instance, we have solid over here. There is a particular form of arrangement that the particles follow. That is why we are having this guy over here in the solid state of matter. Same thing applies to the liquid. There is a particular format that the particles follow in their arrangement, and that's why this is a liquid. And then finally, we have this to be the gas. So now that we know the three states of matter that substances can exist with, let's start with the first one. We have the solid state of matter. So the solid state of matter is a state. Hello, are we together? I can hear some noise in the background.
Yes.
All right, beautiful. So the solid state of matter has a few characteristics that I want us to look at. Characteristic number one is the particle arrangement. The particles of a solid are closely packed together in fixed positions. Now you can see this illustration that I have over here on the screen. You can see some balls joined together or tightly packed together in a fixed position. This illustration is simply showing you what the particles in a solid look like. They are joined together in a fixed position. In other words, they cannot freely move about. You remember in our previous class when we saw the particles of the solid, the liquid, and the gas, we saw that the particles of the liquids were moving, randomly. And then same thing applied to the gas. And then David asked me a question. He was asking why did we not observe any movements happening for the solid? And then I said there actually are movements happening in the particles of the solid. It is just that those movements are very, very small and they are vibrational. David, do you remember that?
Yes.
Beautiful. So the first things about solid is that the particles are closely packed together. The particles only vibrate about their fixed position. They cannot move freely, and then they have a low kinetic energy. Dominic, what's kinetic energy?
It's like a moving energy, an energy that moves.
Beautiful. And kinetic energy is the energy that is associated with bodies or objects that are in motion. So the kinetic energy of solids or the particles that make up a solid is very low because they are not really free to move about. So here are some properties. Property number one is that solids have fixed shapes and a fixed volume. The second characteristic or property of solid is that they cannot be compressed easily. When we say something cannot be compressed easily, it means you cannot, let me use a language that we can understand. You cannot press it down easily. Can you give me an example of a solid that you know, Dominic? I have some on the screen right now, but give me an example on this of a solid that you know that is not on the screen right now.
Table.
Okay, a table. Good. How about you, David?
Stone.
Good, stones. Now, all these things that you have mentioned are absolutely correct, and they cannot be easily compressed. Do you know what it means to compress something, David?
Yes.
Beautiful. What does it mean?
Something compressed is like when you press something to a smaller size.
Thank you very much. I like the language that you use when you press something down into a smaller size. So, property number three about solids is that strong intermolecular forces hold the particles tightly. You will see, let me backdate a bit. You will see these particles of the solid over here. You can see them closely packed together. Did you see that?
Yes, sir.
Beautiful. So the last property is the examples. We have wood, we have iron, and we have ice. That is it for the solid state of matter. So far, so good. Any questions? Dominic, David, any questions?
No.
All right, beautiful. So we have the second state of matter, which is the liquid state of matter. The liquid state of matter is one that we are absolutely very familiar with. And here are some properties about the liquid state of matter. Property number one is that the particles are close together, but they are not in fixed positions. Now you can see this drawing and this illustration that I have on the screen right now. These are the particles in a liquid state of matter. You can see they are also close to each other, but they are not so tightly packed together and they have some space to move. Is that correct? Can you see it?
Yes.
Good. And then the movement in the liquid state of matter is such that the particles can slide past each other, allowing the process of flowing. So for instance, let's say I have a cup, just like this one that I'm drawing on the screen right now. And then I have some water inside of it. If I turn that cup upside down, the water will be able to flow out. Why? Because the particles inside the liquid state of matter can slide past each other. That is why it is able to flow. And then the energy level of the liquid state of matter is moderate. The kinetic energy is a bit moderate. In other words, it is greater than the solid state of matter and less than the gases. Any questions so far? Any questions thus far?
No.
All right, beautiful. So here are some properties of the liquid state of matter. David, you read the first one. Dominic, you read the second one. And then David, you read the third one. And then Dominic, you read the fourth one. Now, the one you are reading, when you're done reading it, you'll explain to us what you understand by the points that you've read so that the class can be very interactive. So, David, you're up. Read the first one. I just labeled it now.
Okay. Water has no fixed shapes. And bracket takes the shape of the container.
Point of correction, not water, liquids, properties of liquids, okay?
Liquid.
Liquids
Okay.
have no fixed shape.
Okay.
They take the shape of its container. So can you explain to us that point? What did you understand by that point you just read?
Liquid, like when it's put in a container, it
Mm-hmm,
takes the shape of that container. If container is a cube, the water
mm-hmm,
and put a liquid in that container, the water will take the shape and look like cube.
mm, mm. I like what you said.
If
I
you
like what you
put in
said. I like what you said. I like what you said. Beautiful. So if there is a cube just like this, and then I put in some water, the water is going to take the shape of this cube. That's correct. How about you, Dominic? Read the second one and explain to us what you understand by the point.
Okay, sir. Okay,
Yes.
sir. Fixed volume.
Okay.
And from our understanding, and
Yes.
what it means that when liquid has a fixed volume, like when it takes the shape of the container or an object, it
Mm-hmm.
takes the volume of that object. Just like it's like water is filled and liquid is put in a cubic container. It
Container.
takes the volume of the cubic container. That means it takes the volume of the container, and the volume cannot easily be changed.
That was the phrase I wanted you to mention. Thank you very much. Now, let me come in at this point. Take note of these two words, fixed and volume. When they say something is fixed, it means it has been stuck to a particular point and it cannot be easily changed. And by the way, volume, you all know, means the amount of space that something takes up. Do we all know that?
Yes.
Dominic, are we on the same page?
Yes, sir.
All right, beautiful. So when they say something has a fixed volume, what we simply mean is that the amount of space that thing will take up cannot be easily changed. So if, for instance, now I give you 1 liter of water, and of course, water is in the liquid state of matter. So if I give you water and I give you one liter, and then you come back tomorrow, that 1 liter is not going to change as far as it's in the liquid state of matter. So that's what we're trying to say, fixed volume. Are we clear on that?
Yes.
Beautiful. All right, David, you're reading the third one. Then Dominic will read the fourth one and we'll proceed from there.
Okay. We can intermolecular forces compared to solid.
Okay, what do you understand by this point?
Like the molecular forces of solid. Hello.
Yes, I'm with you.
Okay, shall I say it again?
Yes, please.
Okay. The molecular forces of
Yes.
solid
Mm-hmm.
are stronger
Mm-hmm.
than the molecular forces of liquids.
Good. Good. So let me explain a bit further. So this property says liquids have weaker intermolecular forces compared to solids. What we simply mean is that the forces that hold the particles of a solid together, they are far greater than the forces that hold the particles of a liquid together. For instance, if I have a stone, which is in the solid state of matter, and then I have, let's say, some milk, which is in the liquid state of matter, which of these two would it be easier to break down? Dominic, can you respond to that question? If I want to break down some stone and I want to break down milk, which one would it be easier to break down?
Stone.
Are you sure?
Not really.
Okay. How about you, David? Do you want to try that question? If I
Well,
have,
I think it should be milk because
of,
it has a weaker force.
that's exactly what we're saying. The weaker, now watch this. The
Mm.
weaker the intermolecular forces, the easier it is for it to break down. So now look at this. Let's say we have two chains now. The first chain is strong, and then the second chain is weak. Which one would it be easier to break? Of course, it's going to be the weak one. Is that correct?
Yes, sir.
Good. So what we are saying now is that the intermolecular forces of liquids, they are weaker compared to that of solids. In other words, the forces that hold the particles of a solid together, they are greater than the forces that hold the particles of a liquid together. And then the fourth property are the examples of liquids. We have water, we have oil, and we have juice. That was supposed to be for you, Dominic, but then That's a no-brainer. So let's proceed. We have the final state of matter that we're looking at in today's class, which is the gas or the gases. So here are some properties about the gaseous state of matter. First things first, we have the particle arrangement. In the gas state of matter, the particles are very, very far apart with large spaces between them. You can see this illustration that I have on this portion of the screen. You can see that every single particle is far apart from each other and they are moving about randomly. So that brings us to point number 2. The particles in the gas state of matter move randomly and they move very fast. That is why you can spray a perfume in a room and before you know what is happening, the smell has filled everywhere up. Am I correct?
Yes, sir.
Yes, sir.
Beautiful. And then the energy level of the particles that make up the gas state of matter is very high. They have a very high kinetic energy. So that brings us now to the properties of the gaseous state of matter. Property number 1. David, can you read that for me?
Okay. Okay. It has no fixed shape and no fixed volume.
Thank you very much. What do you understand by that thing you just read?
No fixed shape, meaning that it can change its shape. It can
Okay.
change its shape.
Okay.
And no fixed volume. It can change in amount.
Okay. Okay. I like I like the analogy you used, but let me explain it this way. First of all, no fixed shape. No fixed shape simply means any container you put a gas into, it is going to occupy that shape. That is the first one. And then when we say no fixed volume, it means that a gas, whatever volume it occupies, that volume can be easily changed. Now, have you ever noticed this thing? Let's say you have a ball and that ball is not really fully pumped, it's deflated. And then you take that ball and put it in the sun for some hours. Have you noticed what happens to that ball? Who has ever done something like that before?
Oh,
David, have you done something like that before?
no.
How about you, Dominic?
Not really.
Okay, so I want you guys to do that. If you have a football at home, it's not really fully pumped. I want you to take that ball and put it in the sun when the sun is up. You put it in the sun for some hours and tell me what happens. But let me tell you what will happen in advance. After a while, you will see that that ball will be more pumped or it will be more fully pumped than it was before you put it in the sun. Why? Because the gas particles inside that ball have expanded to fill the container or that ball that it was placed inside. Are we together?
Yes.
All right, beautiful. So property number 2 about the gas state of matter is that they are easily compressible. Easily compressible simply means that they can be pressed down to occupy a smaller space. That is the principle that we used in our bicycle pump. Dominic and David, you both know what a bicycle tire pump is, right?
Yes, sir.
Good, good.
Yes.
So
Yes.
when you push down the lever in a bicycle tire pump, so usually this is what it looks like. You have a lever like this, and then you have, pardon me, I'm not so much of an artist. Okay. So you have the pipe here that um brings the air into the tire of the bicycle. So when you push this guy over here, when you push it down, you are compressing this space over here. And then the gas has a less space to occupy, which is now pushing it out to enter into the tire of the bicycle that you're trying to pump the tire. So that's what happens in the gaseous state of matter. It is easily compressible. And then property number 3 is that they expand to fill their container completely. That was what I was trying to explain to you with the concept of the ball. If you take a ball and you put it in the sun, if that ball was initially deflated, you would notice that after a while, that ball will look as if it has been fully pumped because the gas particles inside have expanded to fill up the container, which in this case is the ball. And then the second to the last one is that they have very weak intermolecular forces of attraction between them. The forces that hold together the particles of the gas state of matter are very, very weak. That is why they can easily disperse and spread out. And then finally, here are some examples that we have. We have oxygen, as you can see over here. We have nitrogen, and we have carbon dioxide, CO2. Thus far, thus good. Any questions?
No question, sir.
No.
All right, beautiful. Beautiful. So now that we have talked about the states of matter, it is time for us to talk about the transitions that occur between the states of matter. So it is important to know that matter can change from one form to another. You can have something that was solid before, and after a while, you will notice that it is no longer solid. It has changed to a liquid. In chemistry, we are able to explain that through some processes. So the first example we have is the change from a solid to a liquid. When that happens, we simply say that that substance has melted. Are you there? Are we
Yes.
together? Good, beautiful. So we call this process melting, and it is the process whereby a solid is transformed into a liquid. So what happens during the process of melting? Very simple. Particles of the solid gain energy. They vibrate more and then they break free from their fixed positions. So you can see over here, I have some ice cubes, and over here it is still very rock solid. But at this point, you can see that it is already changing to a liquid. What is the explanation? When you apply heat to a solid substance, the particles of that solid gain more energy and then they begin to vibrate more until they break free from their fixed positions. When that happens, then we say that substance has become a liquid, just like we have over here. Are we together?
Yes.
Is my
Yes.
explanation confusing?
Mm, a little.
And what are you confused about?
From beginning.
Okay, Dominic, are you confused about anything?
No, sir.
Okay, I'll explain one more time. So we're saying that when a substance changes from a solid to a liquid, we call it melting. For example, David, when you take some ice and then you put it in the sun, what will happen to it? David, are you there?
Yes, yes, sir.
When you take some ice and you put it in the sun, what will happen to it?
It melts
Good. It will melt. I like that word you mentioned. It will melt. Do you know why it melts?
because heat is being applied on the
Good.
ice.
Good. Because heat is being applied on it. Good. Do you want to say anything else?
No.
Good. So heat is being applied to it. Now, watch what happens. The more heat you apply to a substance, the more energy that substance gains. I'll say that again. The more heat you apply, the more kinetic energy that substance gains. And remember, we said earlier on in this class that kinetic energy is the energy that is associated with a moving object. Do you remember that?
Yes, sir.
Good. So as we apply heat to the particles of a solid, those particles will now begin to move faster than they used to before. So a point comes when they are not able to stay in one position again and then they break free. When that happens, solid now changes to liquid. Is it clearer now? Is it clear now? Hello, David, are you there? Is it clear? How about you, Dominic? Are you clear on that?
Oh, oh, okay.
Hello, David, can you hear me? Hello, David, can you hear me?
Yes, sir.
All right. I think that was a network glitch from my end. Sorry about that. So are we together now? Dominic, thus far, do you have any question?
No, sir.
All right. So the next example of a transition between the states of matter that we have is the transition from liquid to solid. The previous one we saw was when solid changed into liquid. The next example we're looking at is when liquid is changing into solid. So when liquid changes into solid, the process is called freezing. Can you repeat that after me? Freezing.
Freezing.
Good. So a very good example is when you place some liquid, water, in the fridge. Let's say you place a bottle of water in the fridge, and after a while, it becomes solid, rock solid ice. So what happens when that takes place? The explanation is, remember I said previously that the more heat you apply to a substance, the more kinetic energy that substance gains. Do you remember that?
Yes, sir.
Good. So the less heat you apply, it means the less kinetic energy that substance will gain. So when you freeze a liquid and you put a bottle of water, for instance, in the refrigerator, what happens is that that cold environment begins to reduce the kinetic energy of that liquid water. And then those particles begin to lose their energy. And as they lose their energy, they begin to move less and less until they stay in one fixed position. When that happens, liquid water becomes an ice cube. Are you there?
Yes, sir.
Beautiful. All right, now, Dominic, I want you to give me an example of a freezing process. Apart from water becoming ice, what other freezing process do you know?
So I didn't get the question.
Apart from water, you know what freezing means, right?
Yes, sir.
Good. Apart from water becoming ice, what other example of freezing do you know?
Hello.
Yes, I'm with you. David, can you hear me?
Hello. Yes, I can hear you now.
Good. Dominic, are you with me?
Yes,
Hello.
sir. Yes, I'm with you.
Okay, good, good. I thought it was a network glitch. So I was asking you a question. I said, apart from the example of liquid water becoming ice, what other example of freezing do you know that you can share with us?
I'm thinking of like freezing of alcohols to organic liquid, something like ethanol
Oh,
to solid ethanol.
okay, okay. Every liquid can freeze to solid. Okay, that's a good example. Any other example you want to share? How about
Mm,
how about ice cream?
yeah, ice cream. Yeah.
Very good. So the next transition between the states of matter we want to look at is the evaporation or the process of boiling. Now, it is possible for a liquid to change into a gas. A liquid cannot just change into a solid. A liquid can also be changed into a gas. When that happens, we simply say that liquid has evaporated, evaporated, or it has reached its boiling point. There are two ways we can describe it. We either say it has reached its boiling point or it has evaporated. So you can see a pot of boiling water over here. David and Dominic, is that correct?
Yes, sir.
Good. So what happens when you boil a pot of water is that you are applying more heat to that liquid. And the more heat you apply, the more kinetic energy the particles of that substance will gain. So a point comes when the particles of this liquid over here, they gain so much kinetic energy that they can no longer stay in the pot. Now, most of you must have noticed this thing. If you have not noticed it, then I'll say you should stay in the kitchen more often. Have you noticed that when a pot of water is boiling and then there's a cover on top that pot of water, that cover will begin to vibrate as if it wants to fall out. And sometimes, if you're not careful, the steam can make the cover to fall off. Is that true? Yes. Are you there?
Yes, sir.
Yes,
All
sir.
right. All right, good. Sorry, that was a network glitch from my end. The network is really, really networking today. So I was saying that what was the last thing I said? Where did I stop, please?
Say that when you are boiling water and you close the pot
Mm-hmm.
cover will start shaking.
Good, good. Have you ever noticed something like that?
Yes,
Yes,
sir.
sir.
Good, beautiful, beautiful. Thank you very much. Now, what that simply means is that the particles inside that liquid state of matter have gained so much energy that they can no longer stay as liquid. What happens? They now change into the gas state of matter. That gas state of matter is called steam. The same thing happens to your clothes. In fact, evaporation is the reason why your clothes are able to be dry. When you hang your wet clothes on the line and then it's a sunny day, you discover that it gets dry faster than when the weather is not so sunny. Is that correct?
Yes, sir.
Yeah, so what happens is that the sun
Yes,
is
sir.
supplying heat to your clothes, and then the water particles in those clothes are evaporating. And then the next example of the transition of states of matter is when matter changes from a gas to a liquid. So when that happens, we say that the process of condensation has happened. So I have on my screen right now here, um, David, can you tell me what this process is? This one that I just labeled.
Sir.
Yes, can you tell me what this process is? This process that I just labeled. Can you tell me what it is?
Uh, Formation of okay. Formation of dew drops. Uh, it's
Now, have you noticed that early in the morning when you wake up, even if rain did not fall, if you have if you have some grasses around your house, you would notice that there are some water. You discover that
yes,
yes, some water droplets have formed on the leaves of those grasses. Dominic, have you noticed something like that?
Yes, sir. Yes, sir.
Good, beautiful. Now that process is called condensation. Some water vapor or steam rather in the air, they have now condensed back to the liquid state of matter. Now here is another good example. If water is boiling, let me go back to my previous screen. If water is boiling like this that I have on the screen right here, as the steam is coming out like this, the way you have, if you take the cover and you put it to block the steam that is coming, after a while, you will notice that some water droplets will be forming under the cover. Is that correct?
yes.
Good.
Yes, sir.
Good. That process is called condensation. It is the process whereby matter changes from the gas state of matter to the liquid state of matter. Are we following today's class?
Yes.
Beautiful. And then
Yes,
the
sir.
second to the last one is called sublimation. Repeat after me, say sublimation.
Sublimation.
Sublimation is the process through which a solid substance changes directly into the gas state of matter without first becoming a liquid. The previous ones that we have been seeing, we saw how a solid became a liquid and how liquids became gas. Now, it is possible for something to move directly from solid and then it becomes a gas. That process is called sublimation. Are you there?
Yes, sir.
Good. And then the final example that we have is called deposition. So, Dominic, can you read?
Deposition.
Yes, can you read for me what I have on the screen right now? These parts that I labeled.
Yes, sir.
Yes, please. Go ahead.
Deposition is a phase change in which a gas. Jesus. Ah, God.
Are you good? Maybe something came up. David, can you help him out? Can you read these parts that I labeled?
Okay. Deposition is a phase change in which a gas substance changes into a solid state without first passing through the liquid state.
Good. So the first one that we saw was called sublimation, whereby a solid changes into a gas. Now we are seeing the reverse process where a gas changes into a solid, and it is called deposition. Now, here are some practical applications of science to show you that the particles of substances actually move. Can you see what's on the screen right now?
Yes, sir.
Beautiful. So here is activity number one. If you take some food coloring and you drop it in a beaker of still water, just like we saw the video that played out over here, after a while, you would notice something. What would you notice? You would notice that, hold on, let me move back a bit. You can see the food coloring that was placed in this beaker of water over here, right?
Yes.
Good. What did you notice?
That is like spreading.
Yes, that's the word. It's spreading. Even without
Spread.
anybody stirring it, the color was gradually spreading through the water. What does that tell you? It tells you that the particles of water and ink are constantly moving. That is why it was able to spread. Do you understand?
Yes.
Good. And then activity number two is the process of spraying some perfume. If you spray some perfume in a room, what will happen after some minutes? David, are you there?
Just said now.
Okay. If you spray some perfume in a room, what will happen after some minutes?
Diffusion occurs.
Yes, I never knew you knew that word, diffusion. In other words, the gas particles of that perfume will spread to every part of the room. Beautiful, 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 beautiful. So here, those are some practical applications to show you that science is not just limited to the laboratories. They also find expression in our daily lives. Okay, so I want to say a very big thank you for staying with me till the end of today's class. Sorry about the multiple network glitches that we had. I hope to I hope we don't have such occurrences again in our subsequent classes. I have some assignments for you that I want you to do. Can I show you what they are?
Yeah.
All right, good. So I'll send the link for the assignments, but these are the assignments, okay? You have number 1, you have number 2, number 3, number 4, and so on and so forth. So I'm going to drop the link for the assignments in the group. But for now, I want to say a very big thank you for staying with me till the end of today's class. I will see you in the next one, David. Bye.
Bye.
All right, take care.